Alright, so let's say given this problem of a car traveling around a banked curve, and it asks you, at what angle should the banked curve be without feeling any force of friction? To start, we can draw a free body diagram for this situation. We're going to be drawing a free body diagram for the car. Notice the car is at an angle with respect to the horizontal here, and that angle is going to be theta. That's the angle of the banked curve. If we draw a free body diagram here, we have the horizontal and we have this angle theta. So the normal force is going to be pointing in this direction. Since the car is on the banked curve at that angle, we're also going to have the weight force. And the angle theta is also going to be this angle here due to trig. Break down the normal force into the ny and nx direction, noting that this is going to be our coordinate system. And then we also have a rad going towards the right. Since the car is traveling on a banked curve, it is assumed to be traveling under uniform circular motion about a circle with radius r, as seen in the diagram at the start. Note that there's no friction force, so that's what we needed for the question. And so we can apply Newton's second law in both directions. Starting with the x direction, we have the normal in the x, and we also have a rad, so we can plug these both in. The normal in the x is going to be equal to n sine theta because of trig. It's opposite to the angle theta, and sine theta is equal to opposite over hypotenuse. A rad's going to be equal to v squared over r because we're under circular motion. Plug those both in to get this here, but we have three unknowns: the normal, the mass, and theta. So we can use the Fy equation here. We have Ny and weight force, so we can plug both those in. You can note that Ny is equal to n cos theta because of trig. Cos theta is equal to adjacent of hypotenuse. Ny is adjacent to theta. Weight is equal to mass times gravity, and then the acceleration y is going to be equal to 0 since the car is not accelerating in the y direction. Plug these in, and then we could bring mg to the other side, multiply both sides by 1 over cos theta to isolate for the normal. We get this equation here for the normal force, so we can plug this into equation 1, which we have up here. Plug this expression in for the normal, and we get this here. Multiply both sides by 1 over m, and then we can multiply both sides by 1 over g, noting that we're trying to isolate for theta here. Use this property, tan theta is equal to sine theta over cos theta. Take the inverse, which tan inverse times tan, that's going to cancel out, so now we just have theta. And then we can plug in our known parameters for the question, compute the amplitudes into units, noting that there is a typo here. It's supposed to be 5 squared divided by 5 times 9.8, but we didn't do that correctly. Sorry about that, guys. And then the units, we notice here that the units cancel out, which makes sense since we're taking the tan inverse. We get this final answer here, but it should be approximately 27 degrees if we did it properly. And this is the angle for the car to feel no friction traveling around the curve. So if we have our situation here, our angle theta is going to be 27 degrees. That's going to be the angle of the banked curve for there to be no friction.